Hello, so welcome to the fourth video. This video is titled Polynomials Part 1. So far we've been talking about functions and how to combine them and how to graph them a little bit, but we really haven't talked about any specific examples. And really this whole year is about talking about specific examples of functions. And this is the start of that. Polynomials are the most basic functions. They're not always easy, but they are going to become very familiar to us. Again, this is kind of a review video. I don't expect to be saying anything that you haven't heard before in some form, so I am going to be moving a little faster because of that. All right, let's get started. Okay, so what is a polynomial? Well, that's kind of a tricky question. But I guess the simplest way to answer that is a polynomial is a sum of powers of x, or whatever the input variable is, if it's not x. Those powers of x have coefficients, and there might be a constant term. So if that sounded like a handful, well, just look at these examples because they're familiar things. So I have like 3x squared plus x plus 3, that's a polynomial. 5x to the fifth minus 16x squared is, so what do we see? We see powers with numbers in front being added and subtracted together. So just a couple of the maybe more tricky examples. Something like 2x minus 3 still counts as a polynomial. Even though there's no power in front of the x, there kind of secretly is. X is just equal to x to the 1, right? A constant term on its own, like 7, still counts as a polynomial. And if we want to get technical about it, that's because 7 is equal to 7 times x to the 0. You may remember that weird exponent rule that says that x to the 0 is the same thing as 1. So in a weird technical way, yes, that counts too. And then this last one is not a weird polynomial on its own. It may look a little strange, but that's just because it's not simplified. So a polynomial that's not simplified still counts as a polynomial. So what is not an example of a polynomial? Well, negative powers are not polynomials. So for example, x to the minus 1 doesn't count. Square roots, also not polynomials. And you may remember your exponent rule that says that square root of x is x to the 1/2. So that's like a fractional power. Fractional powers don't make polynomials. And then this last one here is, well, it's like a fraction with polynomials in it, but that's not a polynomial itself. That's actually something called a rational function, and we'll talk about those in great detail later on. Okay, so again, just some quick language about polynomials. There's kind of two different numbers that show up in polynomials. The numbers out in front of the terms, the ones that are being multiplied to the powers of x's, those are called coefficients. The numbers that show up in the powers themselves are called exponents. And this is not quite written down, but probably worth remembering. The entire thing that you're adding here, like for example, the 7x squared, that whole thing is often called a term in the polynomial. And when a term doesn't have any x's in front of it, we call it the constant term. Okay. So a couple more words that didn't fit onto the last slide. If you take the largest exponent that appears in a polynomial, we call that the degree of a polynomial. And the term that contains that leading exponent, or that largest exponent, is called the leading term. So in this example that I have here, 3 is the largest exponent, so that means this is a degree 3 polynomial, and that leading term would be 5x cubed. Refresher of a big topic that I know you guys spent a lot of time on in your algebra classes. So I'm only going to go over the basics here. There are 3 methods for solving quadratic equations. Those are factoring, quadratic formula, and completing the square. I think you want to make it your goal in this class and in your future math classes to be comfortable with all 3 of these methods because they all have their strengths and weaknesses. So what I'm going to talk about in this video are factoring and the quadratic formula, and I'm going to save completing the square for a little bit later. Okay, very quick discussion of factoring. I'm going to do this as an example, and the simplest kind of example are the ones where the leading coefficient is 1, so I'm going to start there. So here's an equation that I want to solve. X squared plus 6 equals 5x. Just like with our linear equation, before you're going to solve a quadratic, it doesn't even matter which of the 3 ways you're going to solve that quadratic. You're going to want to start by getting everything on one side. So I can do that pretty easily by subtracting 5x, move it over to the other side. Okay, now when you're factoring, here's what you want. Here's the way I think about factoring. I am looking for two whole numbers, that multiply to the constant number, the 6, and add to the minus 5. Okay, so two whole numbers that multiply to 6 and add to minus 5. And what I'm going to start doing is I'm going to listing out the numbers that multiply to 6, because that's just a little bit easier. There are fewer of those pairs, so it makes it easier to spot the right one faster. So first I might go, okay, how do I make 6 by a product? Well, I could do 1 times 6 equals 6. That works. I'm going to need those to add to a negative number, so I need to put minus signs on both of those to get the sum to be negative. But here the sum is minus 7, so that's not right. So then I go to 2 times 3. Again, I put negatives in front of those to add to a negative number. And when I add those up, voila, I get minus 5. So that's the one I want. That's the pair I want. I take those two numbers, that minus 2 and that minus 3, and I stick them here in my factorization. And that tells me how the polynomial breaks up as a product of linear terms. What's the solution from that? Well, just remember, how do I make these terms equal to 0? Here it's x equals 2, and here it's x equals 3. So those are the solutions. Just a quick note, that 2 and the 3 is not the same thing I ended up writing here. It's minus those. And remember, there's always that kind of flipping thing that happens with factoring. Okay, super quick discussion of factoring, right? And if this is not good enough, then I recommend watching one of the many great Khan Academy videos on factoring. You just might need to spend a little extra time remembering how it works. Okay, quadratic formula is what always works, regardless of whether you can factor something into whole numbers or not. Quadratic formula will never go wrong. It just usually takes a lot longer than factoring. And like I said, I really do think it's useful to know both. So here's exactly the same quadratic. We're going to use the quadratic formula this time. Quadratic formula has an a, b, and a c, as you probably remember. There's no number in front of the x squared, but there kind of secretly is. That number is just 1, so that's my a. The b is minus 5. Remember to include all minuses in this. And the c is 6. What's the quadratic formula? No way around it. Memorizing it, it's minus b plus or minus square root of b squared minus 4ac over 2a. If you've never gotten that annoying quadratic formula song stuck in your head before to help you remember it, then I'll let you look that up on YouTube. It's annoying, but it really does work for a lot of people. What do? We plug stuff in. My b is minus 5, and so I need to take minus that. That's how that becomes plus 5 here. Otherwise, it's pretty straightforward, right? Like here's my a, here's my c. I simplify what's inside the square root first. I notice that becomes 1. Square root of 1 is 1. And then I break it up in the plus and minus into 6 over 2 and 4 over 2. And I end up with the same roots, 3 and 2. Remember, these give you the solutions directly. They don't give you the numbers that go into the factorization, but the numbers but you can turn this into a factorization by writing it as x minus this number times x minus that number. Okay, so that's good enough for today. And like I said, this is fast, so I think it's worth your time maybe supplementing this with a little extra review on either factoring or the quadratic formula if you need it. All right, well, I'll see you guys in class. Have a great rest of your day.